In this video, we're going to look at the roots, or sometimes known as the zeros, of functions. Now, the root of a function is any value that when you input it into a function, you get the answer 0. So if we consider the example f of x equals x squared plus 2x minus 3, we're looking for any values that when we put them in there, any values, this is equal to 0. So the way we can do that algebraically is we can solve the equation x squared plus 2x minus 3 equals 0. And to solve a quadratic we factorise, so we put in our brackets and we have an x in front of both of them, and they add to make 2, multiply to make minus 3. So it's going to be minus 1 and plus 3, and that gives us our solutions of x equals 1 and x equals minus 3. Now that's all very well and good for functions that we know how to solve, such as quadratics or linear functions, but when we have more complicated functions, we can't solve them necessarily algebraically. But what we can do is still plot the graphs, and we can use the graphs to find roots or zeros of functions as well. And the way we do that is we locate the x-intercepts. The x-intercepts of the graph, and they are the roots of the function. So if we look at this graph here, this is the graph of the function we just looked at. This is the graph of f of x equals x squared plus 2x minus 3. And we notice we have the x-intercept here and the x-intercept here, and this one is x equals minus 3, and this one is x equals 1. The same two answers as we got algebraically. We can also look at the other intercept, the y-intercept. We're sometimes asked for the y-intercept as well. In this case, the y-intercept is here. So the y-intercept, this is not a root, this is the y-intercept. The y-intercept would be y equals minus 3. That would be the y-intercept of the function, not a root. It's a different thing. We'll have a look at one more example. This time we have a different graph. This is a cubic graph, but we do the same thing. To find the roots of this function, all we do is we find the x-intercepts, and there are 3 here. There is x equals minus 3, there's x equals 1, and there's x equals 3. So we have 3 roots to this function. There can be 1 root, there can be 2 roots, there can be 3, 4, there can be lots of roots, and in some cases there are also no roots. But a root to an equation is any point where the graph crosses the x-axis. That is what a root, sometimes called a zero, is.